Hello and welcome to the video in which I will going to present the concept of inheritance. But before moving to that concept, I just want to talk about something about classes and object. That what actually is the definition of a class in object-oriented programming and what exactly an object represents too. So but if you look at the definition of a class, which is basically an abstract representation of properties or data and action or methods, right? So class is just an abstract representation in the object-oriented programming. But if we look at another example which says that classes are like templates, and from those templates we can create objects, right? So this is another definition, that classes are templates, from which templates we can create objects. So let's take a look at the example from the real world. So in the real world, when a group of civil engineers want to make an overhead bridge, so before going to the actual field and before starting building the overhead bridge, what they do, they make a plan on a piece of paper and they present that plan to the higher authorities to get approved. And that plan is just a piece of paper on which they includes all the details, what the bridge will look like, what kind of material we're going to use in that bridge, and what will gonna be the dimensions of that bridge, the height, the width, and all that stuff. So that plan on a piece of paper is basically called a class, right? If we consider this in object-oriented programming, or if we simulate this concept in computer programming, so that plan will gonna be a class. Similarly, there is one more example, like usually in printing press. If we go to a printing press and if we want to print thousands of papers, so before actual printing, what they do, they construct a die that fits into the printing machine, and that die is capable of printing thousands of papers. So that die is termed as a class. So these are the basic concept of the classes, that what actually the class mean. Now let's move forward to the concept of object. So what is an object? An object is basically a physical representation of class. And as I have said, the class is a template from which we can create objects. So object represents an instance or physical existence of class in memory. So if we talk about the computer programming, actually when the representation of class, and class is a collection of data and methods, so that data and methods will going to be constructed or instantiated in the memory or RAM. So that when it happens, so that physical, it means that class is now physically existed in the memory. So that physical existence of a class is termed as an object. So let's move forward with the example which I have presented in the previous slide, that based on a plan on paper, the civil engineers actually create the bridge, and that bridge represents an object, right? Similarly, in the case of die, from that die, when a printing machine prints thousands of papers, so those papers actually representation of the objects, and the template for those objects is the die. There is another concept in computer programming about the classes, that how you can understand the class. So basically, in the language, like let's say for example C#, there are certain data types. Integer is a data type which represents 2 bytes in the memory, in the RAM. So when you declare an integer and when you assign some integer value to that variable, it means that 2 bytes will be created in memory, and that value will gonna be inserted in that memory chunk in the RAM. So classes as types, this is another concept, and this is basically very basic concept, that classes are the ability for programmers to create custom data types. Like there are some native data types or pre-built or default data types in the C# language. Those are integers, characters, string, arrays. But if you want to develop your own data type, then classes are here for you. So I think these are the concepts about the classes and object. Now let's move to the next inheritance concept. So what does inheritance means? But before moving to the inheritance, let me present you a structure, a coding structure about the customer entity. So based on the definition which I have given about classes and object, this is basically we are going to create a custom data type like customer, and there are certain properties those are attached with customer. That is the customer name, customer ID, customer address, and there is a method like a customer can place some order, right? So these three properties and the fourth one is the method. These are bundled up or sum up in one representation, that is class. So at this point, this is only an abstract representation of the data or the method. But if you look at the last statement, customer object equals to new customer. So what this statement means, when the compiler starts compile and when we run the program, so what is happen when the execution of the program comes to this line, it will actually create a class representation of data and method in the memory. So what will happen, that the compiler will reserve a space in memory for different variables, different data and the method. So this is just an object representation in memory. So when the object creates in memory, it takes around 302 bytes. How? So what will happen, a space will gonna be reserved in memory, and for customer name the compiler will reserve 100 bytes in memory because it's a character. So one character take 1 byte, so it's basically an array of characters of size 100, so it will reserve 100 bytes in memory for customer name field, and then it will reserve 2 bytes for customer ID because customer ID is of type int, integer, and then it will reserve 200 bytes for customer address, and at the end it will reserve some place for method, which is place order. So when this reservation is done in memory, so we can say that in memory an instance of customer class is created, right? So now let's move toward our concept of inheritance. So what inheritance actually means? If you look at from the computer point of view, from the computer programming point of view, inheritance is the ability of a programming language to simulate the concept of real world heritage, right? What it means, that a son can inherit characteristics of father or grandfather, and those characteristics are like color, height, eye color, and there are lots of other properties. Similarly, there is another concept or another example, that all the belongings to the father will be inherited down to the children, just like the land property or a home property or the gold or all the properties or all the goods related to the father will going to be inherited down to their children. So in the similar manner, if we simulate this real world concept of inheritance in computer science, so the definition will become that inheritance means some of the members like properties or data and methods from the base class is inherited down to the derived class or child classes, right? So just focus on these two words, that base class and derived classes. I will get back to these words later. Now the point is, how can we achieve inheritance in computer programming or C#? So we use classes to represent the model of inheritance in object-oriented programming. So certain terminology we can use to understand when we talk about inheritance. So there is in real world there is a parent and there is a child. So similarly, there is a parent class which is termed as a base class, and there is a child class which is termed as a derived class. So I will use these terms in the rest of my videos, that a child class or a derived class can inherit from the base class. From a diagram we can easily present the concept, and this is the example. This is a classic example of shape. So basically all the shapes, if you look at all the shapes like triangle, rectangle, square, circle, so these shapes can inherit from a base class shape. So in computer program representation, we create a base class and we name that base class as shape, and it has certain properties like height and width, and then all other shapes just like circle, which we can represent a derived class, and these properties height and width from the base class are automatically inherited down to the circle class, which is actually a derived class. And we can also present other classes as well, like rectangle, triangle, and square. So all of these classes are basically presenting the child classes, and the parent class is the shape. So now I'm gonna give you some coding example that how this concept represents in C# programming. So in C# we can declare a class with the keyword class. So we have declared public class shape, and we have declared some of the properties like height and width, and there is a draw method, right? So these two properties and one method can be inherited down to all the classes those will extend or inherit from this base class shape. For example, if we inherit circle from shape, then it means that from the circle class we can access these two properties, height and width. Similarly, a rectangle class can be inherited from shape. So in rectangle class we can use height and width properties of shape. We don't need to provide definition or declaration for height and width separately in rectangle class. So what it do, it can access the height and width properties of shape class. So as an example, I have created a separate method in rectangle class that is calculating the area. So what I'm doing, I'm just accessing the height and width class of the base class shape, right? And the product of these two, height and width, I'm assigning that in the area variable. So that is basically the concept of inheritance. So similarly, triangle class can also inherit down from shape, and then a square can also inherit from a shape. So these was the basic concepts about the inheritance, the concept of inheritance, and how we can represent inheritance concept in computer world or in computer programming. So in my next video, I'm going to show you actual coding in Visual Studio, where we can see that how this inheritance concept comes into action, and how we can program or we can take advantage of this concept in object-oriented programming using C#. So stay tuned for my next video, and thank you very much.